Alright, good afternoon and welcome to another video of the MSU Denver video walkthrough of the Elementary Acupuncture Study Guide. In this video we're going to be talking about inequalities. And really, this should be a pretty short video. I'm going to go over a few things, but this video is this section which is on page 17 is so similar to the section of solving linear equations that I'm going to do let's see here, there are, I believe, 10 practice problems, and I'm going to do number 7 or number 8. The rest should be good practice for you, and you should be very comfortable doing them if you saw the other video on solving linear equations. And if you haven't, I suggest you check that out. But I'm going to go over a few things, a few differences. But really the whole process is entirely the same. There's just one or two added rules, but they're very simple rules that really you should just use this as practice. And really, honestly, 7 and 8 are pretty tough for even just solving linear equations, so I'm going to go over those ones. But I'm going to let you do 1 through 6 and 9 and 10 on your own, just as added practice. But first, let's talk about what inequalities are. Well, like I said, they're pretty much linear equations, except with a linear equation, you're going to have something that looks like this, right? And we all should be familiar with that being the equal sign. And what an inequality is basically not an equal sign. And so what can we have? Well, we could have a sign that looks like this, a greater than or less than, depending on how you look at it, a sign that looks like this, and again, depending on where your solved for variable is. If we're looking for, let's say, x, then this would be a greater than sign, and if x was over here, again, this is what we solved for, this would be a less than sign, because the smaller side is pointing towards x, so x would be less than something over here. And then we have a less than or equal to sign, and again, this is assuming x is on the left, or a greater than or equal to sign, assuming left is x is on the left. And I say assuming x is on the left because if I had something like this, if I had x, and I wrote like this, well, and there was my something over here because that's just how I solved, well, then this would still be x is greater than, because the greater is pointing towards the x. So x is greater than or less or equal to, greater than or equal to whatever's over here. And those what does this actually mean? Well, this means that, and it'll make a little bit more sense once I get into the two problems that I'm going to do, but it means that x is pretty much equal to everything that's, or can be equal to everything that's less than. So let's just say, let's put an example like x less than 7, right? I don't know what x is, but it has to be less than 7, right? So every real number that's less than 7, or maybe raw non-real, but anything that's less than 7, is fair game for x. But it cannot equal 7 because there's not an equal to sign, and it cannot be greater than 7 because I'm telling you it has to be less than 7. When I say like x is less than or equal to, let's say 5, that means everything less than 5 is fair game, but also equal. That's what this little line is here. It's half the equal sign. Less than or equal to, so it can be anything less than 5, but it can also be equal to 5. And what x is exactly, it's unknown, it's a variable, but it could be anything less than or equal to 5. And that's what these symbols mean. But when you're solving for them, which is this section, what they really mean and how we really kind of use them, we'll get into, I think, in the next section when we're graphing stuff, but or maybe it's the section after when we start graphing inequalities. But how we solve for these, it's the exact same procedure that we use that I went over in the linear equation section, solving for linear equations, with the sole exception that if you, and this is actually on page 17, this is in the little box in the upper right hand corner, but if you multiply, see if I can spell correctly, multiply or divide by a negative, you flip the sign. That's the Q. I don't know why I just drew a Q. You flip the sign. I'm not an English major. All right. And what do I mean by that? If I have, let's say, negative 5x is less than or equal to, let's say, 10, then based on the video that we did on the solving linear equations, I'm going to divide by negative 5. And when I divide by negative 5, negative 5 divided by negative 5 is simply 1. So, yay, I have an x on this side, and that's what I want. Well, I'm going to divide by negative 5 over here. And 10 divided by negative 5 is negative 2. But because I divided or multiplied, in this case I divided, by negative, I'm going to flip the sign. So instead of being less than or equal to, I'm going to be greater than or equal to. And that has to do with what a negative really does. When we multiply or divide by a negative, I mean, it's kind of redundant to say, but I'm changing the sign, right? If it's a negative and I'm divide by a negative or I multiply by a negative, I'm making whatever that was positive. And if it's a positive, then I'm making whatever was negative. And so by changing that sign, you know, I need to flip my my inequality sign. And so in this case, if I said negative 5x is less than or equal to 10, then x must be greater than or equal to negative 2. Because if I didn't say that and I chose something that was actually less than negative 2, so let's say 0 is less than negative 2, well, no, I'm sorry, 0 is not less than negative 2. 0 is greater than negative 2. If I chose something less than negative 2, like say negative 3 is less than negative 2 if I didn't flip my sign, and I put it into my original equation, I would have negative 5 times negative 3 is positive 15, and my equation would look like positive 15 is less than or equal to 10, and positive 15 is not less than or equal to 10. Positive 15 is greater than 10. And so because the nature of a negative sign, of multiplying or dividing by negative, kind of flips what our answer is going to be, I have to flip my inequality. I hope that makes sense. I hate to say just trust me, and you could, you know, because I'm correct in this, but I hope that makes sense as far as why we do that. And really, you know, if any of these practice problems in here, you know, try not flipping it and seeing if the answer that you get not only doesn't match, right? Because, you know, you can check your answers in the back, but see if it doesn't make sense. I mean, if you get something that says like 5 is less than 2, that doesn't make sense. So you shouldn't get something like that. So when you plug your variable back into your original equation, it should be something that makes sense. All right, so moving on to the two actual problems that we're going to do in this video. Number 7. Number 7 says we have 2/3, and again, these are difficult for any, you know, whether you know this stuff or not, so I'm just going to go ahead and go over these. 2/3 times 3k minus 1 is greater than or equal to 3/2 times 2k minus 3. And there's a couple ways to do this, and if you're comfortable by just saying, you know, we want to get rid of these fractions, if you're comfortable by, well, I want to get rid of the fractions, so I shouldn't even say this, but if you're comfortable with multiplying or dividing by fractions, you know, I'll just divide both halves by both sides by 2/3, because, you know, if you divide by the left by 2/3, you'd actually, you know, cancel that fraction out, but then you'd have to divide the other side by 2/3, and that actually, you'd have to multiply by the reciprocal. And I'm just going to rewrite my equation, because again, if I put this over 1, right, and this over 1, then it makes sense that I could rewrite this equation as just 2 times, and then in parentheses 3k minus 1 all over the 3, right? I'm just moving into one fraction now, because I'm just multiplying these two fractions. Greater than or equal to, I haven't done anything, so I'm not going to change the sign, absolutely I'm not, but 3 times, and then in parentheses 2k minus 3 over the 2. And if you remember from before, we could cross multiply. And so what my equation would then look like would be 2 times 2. I'm cross multiplying these two. So 2 times the 2 times, I haven't distributed yet, maybe I should have, but it's okay. 3k minus 1. You could distribute if you want to first. And then I still have the greater than or equal to sign. And then I have 3 times 3, and then 2k minus 3. And so as bad as that looked, at the beginning, if we can recognize that, we can just kind of put those two over the one denominator and the one denominator on the right, and then cross multiply. It really doesn't look that bad right now. Before I distribute, I'm just going to say 2 times 2. Well, that's just 4. So I have 4 times 3k minus 1. Ooh, what am I doing? 3k minus 1. We still have the greater than or equal to. And then 3 times 3 is 9 times 2k minus 3. I'm going to distribute, and I'm going to say, okay, well, 4 times 3k, I got 12k, minus 4 times 1 is 4, greater than or equal to 9 times 2k, I got 18k, minus 9 times 3 is 27. I'm going to move my k's over to the right-hand side so that my k's are positive. You don't have to. But if you don't do that, if you move your k's instead to the left-hand side, you're going to end up with negative k's, and then towards the end, you're going to have to divide by a negative. And as long as you make sure you flip your sign when you divide by the negative, you'll get the same exact answer as I do when I do it this way. So I'm going to move this 12k over to the other side. To do that, I have minus 12k, minus 12k. I'm going to combine, since we should be very comfortable with this, I'm just going to do this all in one step. I'm going to get rid of this 27 over here, and I'm going to do that by adding 27. Negative 27 plus 27 is 0. And so I'm going to plus 27 over here. I haven't multiplied or divided by a negative yet, or maybe I won't even need to do that at all at this point. But so I'm going to leave my sign. And so right over on the left-hand side, I have negative 4 plus 27, which is a plus 23. My greater than or equal to sign hasn't changed yet. And then I have 18k minus 12k, so I have a 6k. And if you did it the other way, and you had a, if you subtracted 18k from each side, then you would have a negative 6k on this side, but it would still be, you haven't multiplied or divided by a negative sign yet, so it would still look like this, right? And then when we divided by our 6k, the sign would flip and it would look like ours. It looks like ours is going to. So as you can see, it's gonna by flipping the sign, if we multiply by or divide by negative, it's gonna keep us on the same track. All right. So what do I do now? Well, I still need to get k alone. That's the whole point of these. It says solve for the variable. So to get k alone, I'm going to divide by 6. 6 divided by 6 is 1. Divided by 6. And I get 23 over 6. Oh, there we go. 23 over 6 is well, the 23 over 6 is greater than or equal to k, and we could write it like that, or the answer key actually has the k on the left and k, as long as you make sure, well, this isn't just an equal sign now over here, right? If I'm changing the k to my left, I have to make sure I change the way the inequality is pointing, because I want the left, I want the pointy end, the less than side pointing towards the k, so I have to go like this, k is less than or equal to, and then 23 over 6, and that's actually what's in the back, but they're both the exact same answer. As long as you understand that if you can't just, it's not an equal sign, so you can't just flip the sides anymore. You have to, if you flip the sides, you have to flip the inequality as well. So these are both the same exact answer. It appears like it does on the right-hand side in the back, but they're the same. All right, number 8 is the last one I'm going to do for this. I'm just going to do 7 and 8. And number 8 says x minus 4 over 3 plus 3 less than or equal to x divided by 8. And just like the solving for solving linear equations, I want to get rid of my 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 fractions. But I can't do that until I just have one fraction on each side. And really this, this whole number is kind of like over 1. And so what I want to do, and I could subtract the 3 first, but then I'll have a negative 3 on the other side, and I won't be any closer to, solving for x. And so I'm going to put it as 3 over 1, and then combine it with this fraction over here. And I don't need to do anything to this one over here because I can just have my common denominator as 3. And that one's already 3, so I'm just going to multiply this by 3. I got to multiply this by 3. And so now I'm just going to do this in one step, x. And then I have minus 4 plus 9. Minus 4 plus 9 is plus 5. I hope you can all see what I did there. Minus 4 plus 9, plus this 9 over here, is plus 5. And it's all over 3. And that's still, I didn't multiply or divide by negative, so it's less than or equal to x divided by 8. But I still have fraction bars. And I want to get rid of those before I try solving for x. And so I'm going to cross multiply. And so I'm going to say this 8, and I have to multiply 8 by the whole side, so 8 times x plus 5, just the numerator because I'm cross multiplying, right? And then I have less than, I didn't multiply or divide by negative. 3 times x is just 3x. If one of these were negative, if say this was a negative down here, when I'm cross multiplying, since one of my multiplication is a negative, I do have to flip the sign. I would have to flip the sign. I'm going to erase that, hopefully, because we're not dealing with the negative. My eraser seems to be malfunctioning. It doesn't want the negative to go away. However, and again, maybe at this point it might be easier to do it step by step, but if they were both negative, I wouldn't have to flip the sign because I would, by multiplying by one negative, I'm going to flip the sign. When I multiply by the other negative, I'm going to flip the sign back. So the two negatives kind of cancel each other out when I'm cross multiplying by two negatives. I'm not sure you're ever going to see that in this test, but if that were the case, you would just have to make sure that you flipped it twice, right, or didn't flip it at all because they would cancel out. All right, so now I'm going to distribute this 8, and I have 8x plus 8 times 5 is 40 is less than or equal to 3x. Since I have more x's on this side, I'm going to subtract 3x. Subtract 3x. I have 5, that should be an x, 5x plus 40 less than or equal to 0. I'm going to subtract 40. Subtract 40. And I'm kind of, manipulating it so I don't have to divide or multiply by a negative. But, you don't have to. Again, like, as long as you're comfortable with just flipping the sign, it's not a big deal. Flip the sign if you multiply or divide by a negative. You're going to come out with the exact same answer. And I have 5x is less than or equal to negative 40. Just because I subtracted 40, I'm not flipping. That's only if you multiply or divide by a negative. And now to get x all by itself, the last step is just divide by 5. 5 divided by 5 is 1. Divide by 5. And we get x is less than or equal to negative 8. X is less than or equal to negative 8. I'm just checking my answer, and that's correct. I encourage you to do the rest of the problems. I know there's a lot more that I didn't go over, but they really should be no more difficult than the previous section on solving linear equations, where keeping in mind that you flip the sign if you multiply or divide by negative. And you just treat the inequality sign, like an equal sign. What that actually means, I described a little bit earlier, but what it's really used for, is more in terms of graphing. Really, it helps us with graphing, and it's easier to kind of see when we graph it. And that's going to be in just a few more videos. And I will see you in one of those videos.